is one of what we call the physical sciences. Physics is the other of the physical sciences typically. And I'm a biologist by training, and I say by orientation and philosophy. That's just where I come from. So it took me a long time to love chemistry, and now I do. It was a slow falling in love. But chemistry really underlies what you see in the world. So biology and geology are very descriptive. We look at processes, we describe, we classify. Chemistry explains why those processes happen. And that's one of the things that I kind of love about it. So it is one of the physical sciences, and it is study of matter in a nutshell. Composition of matter, structure of matter, properties of matter, and how matter changes. And we use both direct observations and measurements. We use lots of measurements. And you've already started doing some measurement in here. We also use some inferences. So how many of you remember the difference between an observation and an inference from biology? Okay. Sum it up, Michael. Several of you mentioned observations are factually based. They're what's happening in front of you. They are data collected with your senses. So they are sensory data. You hear it, you see it, you smell it, you touch it, you taste it, though you never taste anything in a chem lab ever. That's observational data. It's very factual. Sometimes it can sound kind of cold. It can sound kind of remote, but it's very, very factual. It's based strictly on observation. Inferences take those observations along with prior knowledge and draw a conclusion from those observations. Okay, I'll give you an example from my world this weekend. We had a big bag of the really good corn chips in the kitchen on top of the refrigerator. My husband and I were both working on projects. You know, he was doing his thing. I was out trimming trees and working in the garden, and he was building something. And I thought to myself, I'm going to have chips and salsa for my little lunch. That's my lunch. That'll be good. And I walked in the kitchen, and there was an empty bag of corn chips. And there was a bowl out on the porch on the table with corn chip crumbs in it. Now, those are my observations. Empty bag formerly containing corn chips in the kitchen, bowl with corn chip crumbs on the deck. My inference is that my husband beat me to the corn chips. Did I see him eat the corn chips? No, I didn't. I can't observe that he ate the corn chips unless I watched him eat them. But I can certainly infer, based on prior knowledge, he likes corn chips and salsa for his lunch too, based on my observations that there are no more and that there's an empty bowl where he had been. It's a pretty easy inference to make that he ate them. That's the difference between an observation and an inference. The observation is purely factual. There are no more corn chips in the bag. There is a bowl with crumbs out on the table. So, observation, inference. Now, there are, in fact, a lot of branches of chemistry. There's organic, inorganic, physical, analytical, biochem, theoretical. Two that were mentioned by you guys were organic and biochem. If I have anybody here who is headed into any medical field, I don't think physician's assistants have to take organic. Pre-med have to take organic. Pharmacy have to take organic. Nursing students typically do not. So the two that I'm really most concerned that you're aware of are organic and inorganic. And organic is the study of carbon-containing compounds, such as yourselves. You are some fine carbon-based life forms. Goes inside. Gasoline is also a feature of study of organic chemistry. Olive oil is an organic chemical. Diesel fuel is an organic chemical, Gesundheit. Aspirin, salicylic acid, is an organic chemical. So these are all things that are primarily composed of carbon, carbon chains, carbon rings, and So because you're carbon-based life forms, many of the chemicals that work in your body are carbon-containing. So hence why pharmacy is heavily organic, chemically derived. Inorganic is what we do here. What you're taking here is inorganic chemistry. And that means we're studying a lot about metals. We'll do lots of metals, lots of metal salts. I mean, we work with metals and non-metals, but we're not doing these things that are heavy-duty carbon, carbon, carbon. I loved organic chemistry. I took it in, I have a chem minor, and so I had a whole year of organic chemistry. And it was the most intense, engaging, challenging class I had in college. And it was awesome. I dreamed, I mean, I seriously, like, it invaded my dreams. I would dream that I was a carbon chain molecule, and my hands and my feet were functional groups, and in my dreams, my body would move, and that would create reactions, and like my little chlorinated functional groups would move up, and methyl groups would move in. It was weird. But it was awesome. If you're going on to major in biology, if you're doing pre-med, any of those, you will take organic. If you're doing pharmacy, you will take organic. Now, physical chemistry, that's kind of the physics of why a lot of chemical processes occur. Analytical chemistry looks at identifying especially new compounds, which we don't do as much. There was a time when analytical chemistry sort of had this golden era. We still didn't know what all the elements were. We were still identifying elements, for Pete's sakes. Analytical chemistry, for instance, one of the big places it's happening right now is the Mars rovers. So those you're familiar with the Mars rovers? Opportunity and what's the other one? Is it Curiosity? Okay, I'll believe you. That doesn't sound quite right to me, but I'll believe you because I could be mixing it up in my head.
I watched one on Opportunity. It was a PBS show.
Okay.
Like a whole...
So anyway, those Mars rovers, especially if you watch something like that, they have an entire analytical chem lab in their belly. They are continually taking samples of rocks, and they're analyzing them for composition. Analytical chemistry relies on a bunch of tools, including spectrometry, what kind of signature wavelengths of light are given off by materials. There are lots of ways, how hot something burns, at what temperature something will ignite. These are all things that you can use to identify compounds. Biochem, this is, if you're majoring in biology, you're really smart to take biochem. If you have to take organic anyway, you might as well go the next step and take bio. If you're doing any kind of medical degree, if you're doing pharmacy, you will take biochem. So this is, again, it's also still largely carbon-based compounds, but now we're talking about how those compounds function in living things. So a lot of biochem is compounds that are produced by living things. If you're going to look at the brain, you have to look at neurotransmitters. These are all chemicals that your body produces that make your brain do things. And then theoretical chemistry, this is kind of out there. A lot of models, a lot of math modeling. If you got to watch The Secret of Photo 51 in biology, did you guys watch that? With Rosalind Franklin. And she did a lot of computation and a lot of calculation to construct a model of a molecule. What molecule was it? Do you remember? You're carrying it around right now.
I sent it down first thing.
DNA. She used mathematical modeling to postulate the structure of DNA. And now they use computers. The kind of calculations that took her years to do, you can do in a few seconds with a computer. So, again, the two that I really care that you can differentiate between are organic and non-organic. So these are the two that I want you to know what they are. Okay? Don't worry about the others. Know those two. Okay. Matter. It does make up anything. It does make up everything. Anything that takes up space and has mass is considered matter. Mass is how much matter there is. You can change your mass by adding matter to your body or losing matter from your body. However, you can change your weight without doing either of those. Weight is not mass. Mass is not weight. How do you change your weight without adding or subtracting matter from your body? No, because that would add or subtract matter from your body.
Turn fat into muscle.
No.
Go to space.
Go to space. Go to the moon. Gravity. That's it. Change your relationship to the planet. Move further away. Weight is not mass. Your mass is the same here as on the moon, but your weight is about 1/6 of what it is on Earth if you're standing on the moon. Your mass hasn't changed. The amount of stuff making you up, the actual amount of atoms making you up has not changed. Mass is the literal amount of stuff that you're made of, that anything is made of. Weight is how attractive you are to the Earth, because weight is the force of gravity acting on you. So your weight is different on the Earth versus on the moon versus on Jupiter. Your mass never changes. Unless you starve yourself or eat all the chocolate chip cookies you can. And that's an important distinction. And I take it probably too far. I find myself unable to say things like, well, just hop on the scale and get a weight. Like when we weigh my daughter periodically, we just check in, well, have her get on the scale and get a mass. Even though that scale is measuring in pounds, which is a unit of weight, and it doesn't translate, I can't say weight. I just can't do it. Okay. Atoms, the tiniest little things. We used to think they were indivisible. Here's the real key to that. They're the smallest unit of an element that maintains the properties of that element. So you can have a single atom of gold. You can have a single atom of copper. You can have a single atom of aluminum. You can have a single atom of carbon. It is this little tiny unit that maintains the properties of whatever chemical it is made of. So elements are made up of only one kind of atom. So I have this lovely foil here. Nice heavy-duty aluminum foil. This is all aluminum atomums. All aluminum atomums. Easy for me to say. I could keep tearing this, theoretically, into tinier and tinier and tinier pieces until at some point I got down to a level where if I went any further, it would no longer have the properties of aluminum. That's the atom. And obviously, I can't even get close to that. We could figure out how many atoms are in this little tiny square of aluminum. Maybe we will sometime. Compounds are made up of two or more kinds of atoms that are bonded chemically. You can't separate them physically. They are permanently bonded. If we think about a bolt and a nut as being atoms, if we screw that nut onto the bolt, that would be a compound. If we think about the bolt and the nut being elements. If we screw the nut onto the bolt, that's a compound. They're joined, and they're joined chemically. We have to do something chemical to separate them. Okay, in here this year you will look a lot at the properties of matter. You'll look at physical properties, chemical properties. You've heard of those. You probably talked about those in physical science. The thing you probably didn't talk about was extensive versus intensive. And extensive properties change based on how much stuff you have. So mass, volume, the amount of energy, the amount of thermal energy that something has, all change if you add more stuff. Intensive properties never change. Doesn't matter how much water you have, whether you have 1 gram of water or whether you have 1,000 kilograms of water. It will still boil at 100 degrees Celsius. It still has a density of 1 gram per cubic centimeter. It is still non-conductive. Pure water is not conductive. We'll talk more about that as we go. It will still convert to a solid at 0 Celsius. Doesn't matter how much you have. Pure water is still got a pH of 7, no matter how much you have. So that's extensive versus intensive.
Quick question.
Okay, the kind of property, you did probably talk about this in physical science, chemical versus physical. You can observe a physical property and not change the substance. So if we take water and freeze it, we can measure the temperature at which it becomes a solid. Is ice the same substance as liquid water? Yeah. Chemically identical, H2O. Looks different, behaves differently in some important ways. The molecules are moving much more slowly. They stay together more cohesively. They don't slide past one another. Has a slightly different density. Well, water's an exception in that. But state is a physical property. We can observe a state change and we don't change the substance. You can melt wax. Doesn't change the fact that it's wax. You've gone from a solid to a liquid. You can solidify it, same thing. Density, yeah, I shouldn't talk about density with water because water's a weirdo. Water's the only substance we know of in the universe that has a different density as a liquid than as a solid. Grr. Were it not for that, life on Earth would probably not be possible. Convenient for us. But we can measure the density of something. It doesn't change what it is. We can measure the density of a steel cube. It doesn't stop being steel. Okay, chemical properties are all about the ability to undergo reaction. So if we observe a chemical property, it has to be going under reaction or being inflamed. When it does that, it becomes a different substance. So if we observe a chemical property, it goes through a chemical change. When we observe that, we're not observing the same stuff anymore. I finally have some actual wood in here. Oops. Okay, this is a big old flow chart. You can copy it down if you want. If you're a really visual learner, you might want to. Your second lab is going to be a physical separations lab. And how many of you did some kind of physical separation in physical science? Typically you get iron filings, salt, and sand. Maybe you got sawdust. Did you get something like that? No? Okay. Most of the classes do that. But we're going to do a similar one. And whenever we look at any substance that we're given, when we get a chunk of matter, we look at, can it be separated, and this should probably say physically. So can it be physically separated? If the answer is yes, it's a mixture. So if I give you a bowl with flour and chocolate chips, can you pick out the chocolate chips? I bet most of you could very effectively pick out the chocolate chips and would be happy to do so. It's a mixture. If I gave you flour and salt, could you physically separate it? Yes, you could. It wouldn't be as easy or as tasty as the chocolate chips. But you would have to do something similar to what you did in your lab with the sand and the salt. The salt is soluble in water, the flour is not. You'd get this nasty gluey stuff, but eventually you could wash all the salt out of the flour mix. So that's a mixture because we can physically separate it. The next thing we want to look at is the air, or is the composition uniform? Is it consistent throughout? And if it is, it's a homogeneous mixture. Have you guys heard, any of you guys pay attention to science news? Read Science Daily or listen to anything. Have you heard about the nitrogen pockets issue? Yeah, you have. It's terrifying, really, because I mean you never know where they're going to be. You can just be walking along, and if you get a sufficiently large nitrogen pocket, you're dead. It's terrifying. Because of course, what happens if you breathe in nitrogen? Yeah, you die. Your body can't use it. You can fill your lungs, you can take deep breaths, but you're not getting any oxygen. So if you get a nitrogen pocket, atmospheric nitrogen pocket, because I mean 72% of the atmosphere is nitrogen, right? You never know where there's going to be a nitrogen pocket. You've heard about this? Yeah. Really? Where'd you hear about it?
I heard about something on the news about it.
Really?
I think
Nitrogen pockets?
maybe it was something else.
Okay.
Please excuse the interruption. All fifth period study halls, please report to the media center. All fifth period study halls, please report to the media center. Thank you.
So, nitrogen pockets? No, not so much. Fortunately for us, the atmosphere, this soup of gases in which you're sitting, is a homogeneous mixture. Take a deep breath. No, really, you can.
I wasn't very.
You should work on that. Every time that you take a nice deep breath, you're getting a pretty even mixture of nitrogen, oxygen, carbon dioxide, water vapor, little bits of argon, xenon. You're not getting a big pocket of nitrogen here, a big pocket of carbon dioxide here, a big pocket of water vapor here. It's relatively homogeneous, which is good because otherwise we would have people dying of walking into nitrogen pockets. You can certainly create an area of atmosphere that doesn't have a whole lot of one particular element or that has too much of it. One of the things they talked about with SIDS, sudden infant death syndrome, with babies, is babies who are face down on a soft surface can form a little, basically, pit around their face, and as they're breathing out carbon dioxide, what's happening? They're creating a pocket of carbon dioxide around their mouth and nose, and then they breathe in carbon dioxide and suffocate. So you can create a non-homogeneous mixture of atmosphere, but in general, the air around us is homogeneous. Kool-Aid should be a homogeneous mixture. Who here has made Kool-Aid? Good. Not, you have homework. The sugar and the Kool-Aid powder are evenly distributed throughout the Kool-Aid. If it's not like that, you're doing it wrong. That's a homogeneous mixture, and that's also a solution. We'll talk more about those later. You can have solid homogeneous mixtures. Stainless steel is one. Anybody wearing any kind of jewelry whatsoever. Most metal jewelry is a homogeneous mixture. So gold by itself is so soft that you could bite it in half. So to get gold jewelry, they mix gold with other harder metals. And that's what means you can't bend your gold ring and just break it. It's a homogeneous mixture. If it was made correctly, you shouldn't have big pockets of silver and big pockets of gold. It should homogeneously be uniform throughout. Okay, heterogeneous mixtures, it's not the same. So, homo means same, hetero means different. Heterogeneous mixtures are different in different places if we take samples from different parts of the material. Granite is one of those, and let's see if anybody recognizes any of these. This is a nice one. Not uniform throughout. Let me pass those around. There are concentrations of one mineral in one place and another mineral in the other, and they are heterogeneous. Your blood is a heterogeneous mixture. There are some areas of your blood that have far more white blood cells at any given time There are some areas of your blood that have high concentrations of oxygen, some that have low concentrations of oxygen. Where would you find a high concentration of oxygen in your blood? On the outside of your lungs, headed on the out track. Coming back in on the other side, being pumped out of the heart back into the lungs, that's going to be a low concentration of oxygen. Over your entire body, your blood is heterogeneous. So that's mixtures. If we look at something and say we cannot physically separate this, then it's a pure substance. And so when we say decomposed by ordinary chemical means, that could be applying an electrical current to it, exposing it to another chemical, which will cause something to jump ship. Those are compounds, more than one kind of atom. If we can't decompose it by ordinary chemical means, it's an element. And elements are on the periodic table. So if it's not found on the periodic table, it's not an element. Basic, simple, straightforward. This is actually where we will pick up tomorrow with notes. I'm going to assign some homework problems. The way that I do homework problems in chemistry, you get lead time. Typically, minimum is 3 or 4 days. And typically, as we go through the chapter, I assign chunks of problems as we hit material. I've done it that way sometimes. Sometimes I've just assigned all of them at once. But the idea is that after we talk about it at least, you go back through and compare to the book and answer the questions. So labs, the big lab packet for lab A1 is due on Thursday. That is the 8th. So that was on the classroom assignment for it. The due date was there. Questions, comments, concerns?
On Doceri.
So the question was if you're using Doceri to do notes. If you did not hit the record button, then it's just a project with no soundtrack, and it'll come up as an untitled project. You can save it, but I think if it's, I don't do that a whole lot. Most of mine are recordings. But if it's an untitled project, I think it's automatically saved. Other questions?